Havuzda kesim. Kesimde iş parçasının yüzeyleri düzensiz ve her iki nozul iş parçası ile iş parçası mesafesi fazla ise nozullardan çıkan basınçlı su, hava ile karışarak türbülansa neden olur. Kesim alanına hava karıştığında deşarj havada meydana gelir, bu durum soğutma etkisini azaltarak telin kopmasına neden olur. Bu nedenle havuzda kesimde, iş parçası ve nozulları suyun içerisinde olduğundan hava karışımı engellenir ve daha etkili bir kesim yapılabilir. Yüksek basınç dijelektriği sıvısını kesilen kanala yönlendirerek soğutma etkisini artırır. Aynı zamanda çok yüksek basınç iş parçasını oynatabilir, bu yüzden yüksek hassasiyet gerektiğinde düşük basınç uygulanmalıdır. İş parçası malzemesi, geometrisi ve kalınlığı. İş parçasının termal karakteristikleri kesim hızını etkiler. Kesilecek malzemenin içinde iletken olmayan malzemelerin bulunması durumunda sık tel kopması ve kesim hızının düşük olması gibi durumlar ortaya çıkabilir. Demir alaşımlı malzemelerde kesim hızı %100 kabul edildiğinde diğer malzemelerin hız oranları tablolardaki gibidir. Kesim öncesi yapılacak hazırlıklar. Kesime başlamadan önce aşağıda belirtilen kontrolleri mutlaka yapınız. Gerekli bakımları yapınız. Başlangıç deliğindeki pas ve kiri temizleyiniz. İş parçasını bağladıktan sonra kafa ile bağlantı ekipmanları arasındaki mesafeyi kontrol ediniz. Kullanılacak kesim şartına göre uygun nozul türünü seçip iş parçası ile alt nozul arasındaki mesafeyi ayarlayınız. Kafaları başlangıç noktasına alarak telin geçip geçmediğini kontrol ediniz. Z eksenini pozisyonlayınız ve mutlaka limit koyunuz. İş parçasının koordinatlarını ayarlayınız. Sarf malzemelerinin durumu kontrol edilmelidir. Deli grafik menüsündeki tahmini kesim zamanı aynı zamanda kesimde harcanacak tahmini tel sarfiyatını da içerir. Bu miktarı Condition menüsündeki Vire Remain ile karşılaştırınız. Enerji plakası, su filtreleri ve reçinelerin ömürlerini kontrol ediniz. Tank seviyesini cetvelden kontrol ediniz. AC Function menüsünde uygun tekrar deneme ve RWB modunu seçiniz, elektrik koruma durumunu kontrol ediniz. Elektrik kesintisi durumunda tezgah açıldıktan sonra makine referansına gideceğinden bu hareket esnasında kafaların iş parçasına ya da bağlama ekipmanlarına çarpmayacağından emin olunuz. Approach fonksiyonunun açık olduğunu kontrol ediniz. Girişlerde ve koparma aşamalarında telin kopmaması için bu fonksiyonu sürekli açık tutunuz. Test çizimi modunda programı çizdirip tahmini kesim zamanına bakınız. O ve eksenlerini iş referansına alınız. Hafıza konumunda çalıştırılacak programı çağırdıktan sonra kesim izleme menüsünde grafiği çizdiriniz. Kesmeden çalışma modunda programı çalıştırıp kafaların hareketlerini kontrol ediniz. Eksenleri belirlenen referanslara alınız. Tüm bu hazırlıklar ve kontroller tamamlandıktan sonra programa start verilebilir. İş parçasını hazırlama ve bağlama. Tel erozyonda hassas bir kesim yapabilmek için iş parçasına uygun hazırlamak gerekir. Kesim esnasında ortaya çıkabilecek gerilimlerden dolayı kesim esnasında parçanın dönmemesi için önceden tedbir alınmalıdır. Nozul çapını ve bağlama payını göz önüne alarak iş parçası malzemesini hazırlayınız. Malzeme kenarı ile işleme yolu arasında 10 milimetrelik bir boşluk bırakmayınız. Gerilimin neden olduğu problemleri engellemek için daha fazla boşluk bırakılmalıdır. Ön delik çapını gerekenden daha büyük yapmayınız. Delik iş parçasına dik olmalıdır. Delik içindeki pas, toz, çapak ve benzeri temizleyiniz. Bir kural olarak her işleme için bir delik hazırlayınız. İnce bir profil işlendiğinde, koparma parçası kalın olduğunda ya da malzemenin geriliminin alınması istenildiğinde farklı işlemeler için çoklu başlangıç delikleri hazırlanmalıdır. Ağır iş parçalarında önceden hazırlanan kılavuz deliği ile malzeme çektirilerek taşınabilir. Böyle bir işlemde çektirme aparatı takıldıktan sonra tel kopma durumu olduğunda nozulların bu aparata çarpacağı göz önünde bulundurulmalıdır. İş parçasını tablaya gerilim problemi yaratmayacak, su basınçlarından dolayı yer değiştirmeyecek ve malzemenin ağırlığını taşıyacak şekilde bağlayınız. Bağlantı plakasının yüksekliğini mümkün olduğu kadar kısa tutunuz. Ayar cıvatalarının nozullara ve kablolara zarar vermemesi için mümkün olduğunca kısa bağlayınız. Kalıp plakası X ve Y referans eksenlerinde doğrultma yapılarak plaka tezgah tablasına bağlanır. Tezgaha bağlantısında komparatör kullanılarak dikliği ve paralelliği kontrol edilir. Makine referansı, makine orijini ve iş referansı. Makine koordinatı tezgahta bulunan eksen switchlerine bağlıdır, değiştirilemez. İş tablası üzerinde herhangi bir noktaya yeniden gelindiğinde makine koordinat değeri de aynı olacaktır. Y, Z koordinatları her zaman aynı olmakla birlikte, U ve V koordinatları diklik ayarı yapıldıktan sonra bir miktar değişkenlik gösterebilir. Her bir program için X ve Y iş koordinatlarının 0 olduğu noktadaki makine koordinatı bir yere not etmekte fayda vardır. İş koordinatlarının yanlışlıkla değiştirilmesi durumunda kaydedilen makine koordinatlarına gelinip yeniden sıfırlama yapılabilir. Makinenin ilk açıldığında gitmesi gereken konumdur. X ve Y eksenlerindeki referans noktası tablanın merkezidir. U ve V eksenleri ise telin dik konumda olduğu noktadır, Z ekseninin referansı ise üst kafanın en üst noktasıdır. Özellikle gece çalışmalarında elektrik koruma fonksiyonu açık bırakıldığında elektrikler geldiğinde makine otomatik olarak açılarak bu referansa gidecektir. Bu hareket esnasında kafaların bağlantı ekipmanlarına çarpma riskini göz önünde bulundurmak ve buna göre tedbir almak gerekir. İş koordinatı, işlenecek malzemenin ensi programı hazırlanırken öncelikle eksen hareketlerinde referans alınacak olan bir sıfır noktası belirlenir. Makine tablası üzerinde de tayin edilmesi gereken bu nokta, iş referansı olarak adlandırılır. İş koordinatı ise, bu noktanın sıfırına göre görülen sayısal değerlerdir. İş parçası koordinatı tablo içerisinde herhangi bir konumda tanımlanabilir. Program iş parçası koordinatına bağlı olarak çalışır. Hazırlanan ensi programındaki komutların referans alacağı noktadır. Her bir program için ayrı bir referans noktası tanımlanmalıdır. Tel istenilen noktaya geldiğinde bu noktadaki X, Y ve Z koordinatları sıfırlanarak iş referansı tayin edilmiş olur. Makine ilk açıldığında makine koordinat sistemi tanımlanması gerektiğinden eksenler mutlaka makine referansına gönderilmelidir. Ölçü koordinatı, tel malzemeye dokunarak kenarı, delik merkezini ve benzeri bulabilir. Bu tür pozisyonlamalarda telin malzeme üzerinde dokunduğu iki nokta arasındaki ölçü bu koordinattan okunabilir. Özellikle dişi kalıplar kesildikten sonra istenen ölçünün elde edilip edilmediğinin kontrolünde kullanılabilir. Tel Erozyon tezgâhında pozisyonlama. CNC tezgahlarında makine eksenleri istenen noktalara sayısal koordinatlarla ve komutlarla gönderilir. CNC tel erozyon tezgahlarında da tel kesim yollarını bu komutlar ve sayısal koordinatlar belirler. Günümüzde bu komutların hazırlanmasında CAM programlarından faydalanılmaktadır. Bu yüzden manuel olarak program yazma gereksinimi ortadan kalkmıştır ancak kullanıcının çıkan problemleri kısa yoldan giderebilmesi ve daha verimli çalışabilmesi için program dilini anlaması gerekir. Aksi takdirde kısa sürede çözülebilecek bir işlem ya da problem saatler sürebilir. Programlama dilinde bilinen G ve yardımcı M kodları kullanılır. Günümüzde kullanılan iki koordinat sistemi bulunmaktadır. Mutlak koordinat sistemi, tüm koordinatlar iş sıfırına göre verilir. Telin gideceği nokta ile iş referansı arasındaki mesafe programlanır. Eklemeli koordinat sistemi, telin bulunduğu nokta sıfır olarak kabul edilir. Telin gideceği nokta ile bulunduğu nokta arasındaki mesafe programlanır. İki farklı sistemde yapılabilen programlamada telin iş parçasına göre konumunun tezgaha tanıtılması, pozisyonlanması gerekir. Tel Erozyon tezgahlarında pozisyonlama iş parçasının kesim yoluna göre farklı şekillerde ve farklı G kodları ile yapılmaktadır. Kenar pozisyonlama. Delik merkezi pozisyonlama. Köşe pozisyonlama. Kanal merkezi pozisyonlama. X ve Y ekseninde iş parçası kalınlık merkezi pozisyonlama. X ve Y ekseninde açı bulma. Silindir merkezi pozisyonlama.
Hello. In this video, we're actually going to go over how to operate the machine, but what I wanted to show you first is the program, the G code that I made that we're going to use. So this is the part we're going to cut. So it's a handful of gears. What's interesting about this one is I actually have teeth on the inner ring and teeth on the outer ring. So I'm going to walk you through I broke this up into 3 different programs: the inner ring, the outer ring, or the outer teeth, and then the cutoffs. And I'll show you how this is set up, and then we'll take this over to the machine. So the first thing that we're going to do is the inner ring. So I'll just open it up. I've already done it. So inner cutout. I don't need to save. So for the inner cutout, I'll just come over to how I have it. So we'll do all of the roughing passes, and then what we'll do is come around and do the cutoffs. So you'll see the cutoffs here. Okay, so basically all I did was I'm happy with this. This is what I'm going to run, and so this is what I exported. The next thing we're going to do is the teeth profile on the outside. Give it a second to load. So on this one, so what I'm zoomed in, this one runs a little slow because there's actually quite a bit going on. So with this one I actually broke up into segments, and I used open right and open left rather than full contours. And then I just had 3 cutoffs. So this way, with these gears, I don't actually need to glue them in place. I'll just come back and do the cutoffs. So this is the second file that I outputted, and then the last one is just this cutoff. And here you see I just come around and I just cut off each one. Well, I'll take you over to the order. So boom, boom, boom. So that one would be free. And then I go on and so forth. Okay, so these are the 3 programs that I outputted. And now we'll take it over to the machine. So we are going to be cutting this part today. So once again, the first thing that you do, as always, once you're going to operate on the machine and move the machine, is you're going to come over here and turn on the pumps. Once again, you see this deionization message. That's fine. That's just because it's getting up and going. So we're going to come over here, raise up the water so that way the seals are lubricated. Turn on the light. And once again, the first thing that we're going to do is we are going to clean up the table. So we're going to wet our abrasive pad. We're just going to lightly scrub down the entire table, getting any residual material off of there. And we're going to spray it down. So I'm going to set up the part on this side. So what I'm going to do is move the head out of the way and kind of raise it up so I have as much space to work as possible. So the next thing we're going to do is we're going to grab the holders for securing your part. So you'll find them over here in this cabinet. Wire EDM tooling, they'll come in this box. So here is the tools that you'll need. When you use this, please make sure you put everything back, especially these hex keys which go with this, and keep it organized and dry. So what we're gonna do, mainly what you're gonna use is parts like these. So you need to know how big your part is. So this lip will help you secure it, but notice how the part is bigger than that. So we're actually gonna secure it this way. So now what we need are bolts that will be able to bolt into the table. So that one will be able to go past. So I'll take 2 of those, these, and then you also need the appropriate part to pin it down. Now we're ready to secure the part to the table. So I'm going to position it across there. So this is where we're going to screw the part into, and they actually have these little protector studs, and what these do is they prevent material buildup on the threads so that we can continue to use these holes. So they look something like this. When you take one out, we've lost some of them, and so just place these in an open hole. So what I'm going to do is secure the first one. So all I'm going to do is get the thread started, kind of get it to where it would be level. And then so we don't scratch up the table, we put this protective layer under the back thread. So what you want to do is you want to get it so that the clamp is essentially level with the part, and that's where you want to tighten this down. So wait until that it gets level, and then what you want to do is you want to tighten the first one, the front one, and then slightly tighten the back one. And what that does is gives a kind of a pinching pressure to it rather than lifting off. And so now my part is secure. You don't need to wrench on it because there is no cutting force with this. So now we're going to do the back one. Okay, so now my part is in there secure, and we're good to go. Kind of just kind of a note on clamping your part. This is very dependent on how big your part is, how well it needs to be secure. So if you have a flimsy part that flaps quite a bit, then you will kind of have to hold it tighter. If you have a bigger part that weighs quite a bit, you might need 3 or 4 spots. So this is all kind of dependent, but make sure that whatever you're clamping, the connection to the table is complete. If you don't complete the circuit, then you're not going to be able to cut. So now what we need to do is find the part. So the first thing that I do is you'll see here the rot number, and what this is showing is that there's a rotational offset. So the very first thing that I do is I zero this out just to make sense in my head. So what this is an MDI rot, the coordinate system that you want to zero out, and then 0. So if I run that, that'll go to 0, and we're fine there. So now the first thing I'm going to do is find the origin of the part. If you did add a part system setup, then you need to make sure that this is the same as that. If not, then you just need to find the spot where the wire is going to start in your part program. So I'm going to go over generally where the hole is. And so sometimes it can be kind of hard to find where the hole is. So I'm going to give you a little trick that helps out. We're going to close the door. And then what I'm going to do is I'm going to turn on the jet. And that's going to let me know where the head's at. And then I'm just going to move it until the jet is in the hole that I'm aiming for. So there we go. That might have been hard to see, but hopefully you understood what I was doing. So now when I do the thread, the jet will also go through that hole and I'll thread in the correct hole. One way of knowing if the threading is not performing well is you see this cantilever bar, it'll start bouncing if you're not threading very well. So what we're gonna do is we're gonna go over to the measure tab, but first actually I'm gonna turn on the chiller, and that is because you want the measurement to be done in the same kind of setup as you're cutting. You'll get higher tolerances. So now what we're gonna do is we're gonna come over to the measure tab, and what I'm gonna do is I'm gonna do a center finding. So with center finding, there's a couple different things that you can do. The top one is what coordinate system that you wanna set, and we're gonna do the part. The next one is how many touches do we wanna have. I typically do 5. You know, you can do however many you want. Technically, to find the center of a circle, you need at least 3. You can even change how many degrees apart. I'll do evenly spaced at 72. This is asking how much rotation do I want to add, and we're going to add none. And then this is asking what point do I want this in my coordinate system. So if I put this as 1, 1, when it finds it, it'll do 1, 1. So I'm going to do 0, 0 because I want this to be my origin. And then this is what sort of profile you have. So ground face plus means that it is an accurate, basically you have a grounded off surface that's accurate, and if it finds that there's a point that's out of tolerance, it'll actually not complete this task, basically telling that you have a problem. If you have a rough face or a rusty face or something like that, choose rough or rusty, and then it won't, it'll just do a best fit, and it'll try and do its best at that, and it will never fail. So we're gonna do ground face plus because this is an accurate hole, and we're gonna hit go. So now what you should see is, so now we're in the program, it's going to fill up with water. You're gonna see the wires start to go. And then once the program starts going, you'll see that the machine is gonna start moving, and you'll see this edge being flickered on and off. This means that it's touching the edge and it's finding your part. And this is gonna take a couple of minutes to run, and you'll see either, if it doesn't complete, you'll see an error, or you'll just see that you're at 0, 0 and the part will be out. All right, so now we found the center, we've basically found our origin. So the next steps are, first you want to cut it so that when you move the machine, you don't just drag the wire into the part. So we're going to cut it. We're going to come back over to manual, and we're going to lower it down. So the next thing that we want to do is find basically the rotation. So if you see how I put the part in, so the machine coordinate system is X that way and Y that way. So positive X, positive Y. And how I put the part in there is a negative 90 degree rotation. So we need to find that rotation. So what we're gonna do is, I know that these holes are in a line. So what I'm gonna do is I'm gonna find this last center hole over here. So once again, I'm gonna move over there. I actually have a small stream of jet of water, so I kind of know that I'm in the right spot. Actually, I'm going to back up. I'm going to give it the big jet. Make sure that we're lined up. That looks pretty good to me. We're going to thread it. Okay, so now what we're gonna do is we're gonna come back over to the measure, and we're gonna go to the CAL, the CAL, and this is to be performed after you do a centering, and what this does is find the angle between the line linking the two center holes. And so once again, we're gonna do part, we're gonna do 72 degrees in between, and once again we want 0 added rotation because our x-axis and our part coordinate we want lined up with the x-axis of this. So this is going to tell us how far to rotate our x-axis, and we'll do ground face plus. So we'll give that a go. Once again, we're in the program, and this is going to perform exactly how the center finding went, and now at the end of this we'll see a number in the rote column. All right, so the cowl just finished, and what you'll see here is in the rote, it's 269.965 degrees, almost exactly 270, which makes sense because basically we had a negative 90 degree rotation, so everything feels good, so we're gonna continue on. So once again, the first thing to do is cut the wire so that I don't drag it into the part. I'm gonna lower the tank down. And then what I'm gonna do is move this back to 0. And so I'll just use that quick key of move. And this will take me to my 0 position. Lower this down. Okay, so now what you want to do, this is right before we're ready to start programming our part. What you want to do is set your height right. And so I can actually hit these. And so what I'm going to do is I'm not going to set my my nozzle right on the surface. I'm going to set it right above where I won't interfere with that. So I'm just going to kind of eyeball it. I'm going to come in here. And I'm just gonna make sure that my head will always clear anything. So I'm happy with this. And so this is basically the setup that I want for the start of this. And so what I'm gonna do is I'm gonna come over here and I'm gonna hit the SEP1CP. What this is gonna do is basically set up my point 1, and this is basically where my origin is. So now what we're ready to do is set up the part. Or set up the program. So you take the flash drive that you added your ISO files to, and you come over here and insert it into the flash drive over here. And now we'll use these other 2 tabs. So come to your file manager, and what you'll now see is that the flash drive is there in the F. What I'm doing is I'm gonna import everything from the 06 folder that I have. Never run anything off of your flash drive. So always copy this and bring it onto the user drive. So I already have a folder set up for me. And so I'll just go through this. I'm gonna add it here. So now paste it here, and now here's my 06. This is what we're working out of. And now what I'm going to do is I'm going to add the first file that we're going to do, so the inner cutout. I'm going to import that. That's going to come in, and what you should see is no red. Everything looks fine. If you look over here, this looks like what we want to import. You can even zoom in, make sure everything looks okay. So now what we're going to do is we're going to import the other files that we're also going to be using. So you're going to come over to this new. Oh, sorry, not new. That would literally, you could create your own G code. We don't want to do that, so delete that. Okay, we're gonna come over to import again, and we're gonna select the next one we want to do, which is, we want to go to the 06 folder, and we're gonna do the teeth profile, import. It takes a little bit to import. That comes in. That looks okay. That also looks okay, the picture. And so we're gonna import one more, which is the cutoff. Import. And so now we have all 3 imported. You'll see them up here. So now, basically we're gonna go in order of these tabs. That's what we're gonna do to create it. So the first thing that we need to do is create the tech files. And if you remember, we talked about them when we were doing this on the Esprit side. We need to match it up on this side. So this is kind of your GUI to create a text file. So the first thing you want to do is select the material you're working with. If you're working with steel, there's steel and steel plus. I typically go with steel plus. Then you want to go with your part thickness. I will say that it doesn't exactly allow you to go too low with the part thickness. So with mine, it's less than 1/4 inch. And so we're going to put 0.2. If you have thicker, it's good to put the exact amount. Over here is kind of a filtering of which tech files you're allowed to select from. I zero everything out just so I can see them all. So below is the selection of the tech files you can use. And here is the type of wire that we're using. You're typically not going to change this. So here you can select through all of the different tech files. Over here, NBP is the number of passes. So what we need to do is we need to create a 4-pass, a 3-pass, and a 1-pass. So that's what I'm going to do first, is I'm going to create this 4-pass. I only have one option, so that's what we're going to do. So I'm going to do generate. And then this is very important. You have to name this exactly what we named this in the in this brief file. So 4-pass. And then I'm going to do validate. So now this creates my 4-pass file. And then I'm going to create our 3-pass. So I'm going to come back in here. And now you notice that I have 2 options for my 3-pass. The differences are in the TKM and the RA and the speed. So TKM is essentially your accuracy and how the lower the number, the better it is. And the RA is your surface finish. Once again, the lower the number, the better it is. And the speed is your surface speed. And so the higher it is, the better it is. And if you notice between the 2 of these, one basically is more accurate but slower, and the other is less accurate and faster. I'm going to choose the slower but more accurate run. Generate, and then name this 3-pass. Okay, we're going to do that. And then the last one is the 1-pass. So I'm going to come in one more time, and I'm going to select 1-pass. This one honestly doesn't really matter which one you pick. Okay, so now the next tab is the operations tab, and what we're going to do here is we're going to set up our op organizer. Essentially what we're telling the machine is the order of operations that we want to go. So first I'm going to choose my inner cutout. That's what I want first. And then what I'm going to do is I'm going to select MP, which means I'm doing multiple passes. I suggest always checking this. If you're only doing 1 pass, this has no effect. If you're doing multiple passes and you forget to turn this on, it can have pretty bad effect. Now you need to tell it which tech file you want to use. And so for the inner cutout, we're doing a 3-pass. And then what we're going to do is we're going to add another file. Well, this is going to be the next thing that we want to do. And this is the teeth profile. And we're going to do 4 passes. And then the last one is we're going to do the cutoff. And we're going to do 1 pass. Now what I do is I come over to positions, and this helps organize things, and this makes it so that basically I can move the machine wherever I want, and the part always, and this always runs correctly. If you don't do this next step, you need to make sure that the machine is at the right position when it starts, basically where it thinks that it's going to thread, or else it's just going to cut the profile exactly how it is, and it's not going to move to the right spot. So what I'm going to do is I'm going to tell it basically where the origin is, and this is going to be that point 1 that we created. So if you do that SEP1, you can do this. All right, so now that we've set all the points to point 1, I'm going to do generate, and what this basically does is it just generates a bunch of code that organizes and makes sure the part programs run in the order we want. The last thing that we want to do is come down to this verification tab, and what it takes a little bit to load, but essentially what this displays is what our part program will look like. Okay, so there, now we can kind of see the outline, and what we want to make sure of is that nothing is outside of the boundaries. Honestly, this takes up quite a bit of resources and can be pretty slow. But one good thing is that this is lined up the way we want. Everything looks good. We should be feeling pretty good at this point. So this is taking quite a bit, so I'm just gonna go to the execute. So the last thing is just hit execute and the part will run. So I like to be on the information tab when I'm doing this. What I normally do is I just zoom into the first point. Okay, and so now basically the program's waiting for us to go, and all we do is hit go, and it should start running. And that's the whole process of taking your programs that you made from a spree and getting them onto the part, onto the EDM and making a part. So thanks for watching this video.
Tel Erozyon tezgahında çalışma. Çalışma ortamınızı hazırlayınız. İş önlüğünüzü giyiniz. İş ile ilgili güvenlik tedbirlerini alınız. Tel Erozyon tezgahı ana şalterini açınız. Tezgahı kurallara uygun olarak çalıştırdığınızdan emin olunuz. Tezgah kontrol ünitesinin çalıştırınız.
Always use safety first, so there's quite a few moving parts on this machine and also electrical parts. So anytime that you're going to be operating the machine while the door's open, you should have safety glasses on. So anytime door's open and you're going to move the machine or you're going to do maintenance on the back like greasing or anything like that, always make sure to use proper safety equipment. So if you come over here, we'll look at the screen. So you have, this is broken down kind of into 5 major categories, and then each one is broken down into 5 minor categories on the right. So the first one is actually kind of the file manager, and this is where when you plug in your ISO files, this is where we grab them and we can load them on. I'll go into more detail on this in later videos when we go through how to cut a part. The next one is actually where you go to build the MJB files once you load an ISO file. Once again, this will become clear in future videos. This video, what we're gonna really focus on is the manual screen. So this is kind of where you get a general picture of the machine. You'll spend a lot of time here when you're not cutting parts, but when you're setting up. So the top left corner is your coordinate system. So your part coordinate system, your cutout, and you can also switch to the machine coordinate system. So you'll use these for setting up parts and kind of debugging. The next one is your upper and lower injection. This is your to apply high pressure jets. Once again, this is kind of used for debugging, and I'll turn these on once we turn the water on. The other one controls the level of the tank. Here you can see the temperature of the water, which we want to keep at about 70 degrees. This lets you know your deionization level, and while we're going, we want to keep that at 10. This lets you know how much wire you have left. This is your panel for controlling whether the wire is cut, whether the wire is feeding. These are all manual controls. This is the pressure of the filters, which lets you know if the filter needs to be changed or not. And here are some user buttons that are useful. So I'm gonna start going over kind of the normal operation. So the first thing that we do is we come over to this maintenance page. Most things on the maintenance page you will not be changing, but the first thing you do every time with this machine is you turn on both of the pumps. So now we can hear both of the pumps running, and we can actually see that the pumps have turned on. Okay, so now that we know that's working, we're gonna come over to the manual page, and oftentimes you'll get a deionization out of range, and that's fine. That's because the water's been sitting there stagnant, and it takes a little bit to bring the deionization level down. So the first thing what we wanna do is we wanna fill up the tank. So this is the button that says bring the water up to the table, so you'll see that we can do that. I'm also gonna turn on the light in the tank, so that's this button over here. So now we have some light. You can see that the water is up to the table. The reason why I did that before we did anything else is because when this machine moves, it actually has seals that are lubricated by the water. So if you don't have the water up, we'll wear out those seals earlier. The very first thing that you wanna do is you wanna take this abrasive pad, you wanna wet it a little bit, and you wanna gently rub down the table. What this does is it keeps the table in pristine condition, and we keep everything flat. This will help keep parts accurate. Once you do that, you can take this, which is a water gun, and you can gently spray everything off, and that'll get any leftover residue on there. Now just going over some manual control of the machine itself. So here we have the pendant, and this allows us to move the machine around. So this will control what speed we move at. Notice we can't go up to level 4. We can only go up to level 4 when the door is closed. So here I'm going to go to level 3, and I'll move in the X direction. So this is the positive X direction. This is the negative X direction. Negative Y direction. Positive Y direction. Negative Z, and positive Z. So we're going to come down, and I'll go over some other manual ones. So what we're going to do is we're going to thread the wire, and we'll manually thread it by hitting this button here, the thread button. So we'll do that, and you'll see that the machine is now in a program, and that's the automatic threading program. So right now it's going, and you'll hear the high pressure jet turn on, which will help feed the wire. So when that completes, this light will go dark, and we will have the thread light on. So that means that the wire is threaded, and we can actually see it. It might be hard to see on video, but there's actually a wire that's threaded right there. So now, if we want to do the cut, we actually have to close the door. So to close the door, give it a good shove and then lock it. Now that the door is closed, I can press the cut button. And once again, now we're in the cut program, and once it's finished, this will stay solid, meaning it's in the cut state. Okay, now that it's threaded, if I hit this button, it'll just continue to thread the wire, and you see that the spool continues to spin. So that ended that. Okay, so now we'll come back over here, and we'll go over a couple operations over here. So I think the first thing that I'll do is I will go over the operating buttons here. So the first one is MOV, and what that is doing is it's going to take you to the part 00 position. So if you just hit MOV, you see that it just goes to the 00. So this is a random 00 position. And what that is a hotkey for the MOV. So on MDI, the MOV quick function. So what this is asking for is MOV, which coordinate system you want to move in. So we moved in part, and then what value you want for X and Y. So I'll go to X 1, Y -1. And all this button is a hot button for going to move MOV, comma, part, comma, 0, or X0, Y0. And that's all that's useful for, and it's just kind of to help you get there faster. What SDP1CP is this is set point 1, and this will come into play when we're doing part programs. But if I set point 1, all this will do is, actually I'll move to a random spot. I think it'll make it more obvious. So I'll say that this is my set point 1. And just to remember that my set point 1 is negative 0.85 in X and negative 0.77 in Y. And then if I just move to some arbitrary position and I hit GOP1, it'll go to my set point. So now we're back to that exact set point. And so this is very useful when we're doing part setups. We don't need to go over what SAXP is, but UVP0 is important. What this is if your U axis is not aligned, so I just misaligned my U and V, notice that the coordinates changed. If you do UVP0, it'll realign them. And this is useful because when you try and measure something or other ones, this will ask you to realign them, and all you do is come here and press this button. And then the greasing one, I go over in the greasing tutorial. So see that if you want more information. The other hotkeys that we can go over are, if I lower it, what I'm gonna do is, you have to have the door closed for this. What I'm gonna do is raise the water level to the height of the head. And so this one wouldn't allow me to do it if the door had been open because it would spill out. It also doesn't allow me to open the door, it's locked. It won't unlock until we bring it back down to the table. So now this is at the, you can see that the water level has been raised. Now what we can do is we can turn on the jets. So this allows you to test what you want the jets to be at. So what this is saying is turn on the jets to 2 PSI. So if I do that, it takes a little bit, but then, oh, sorry, they were turning on. I just don't hear them. So the reason why I don't see any pressure is there's nothing in the way. These will measure kind of when you're close to a part, how much pressure it's seeing. And since there's nothing there, I don't see anything. But you do hear it turning on. You can see the water moving. This is saying I want 15 PSI coming out, so you can change this. But really, there's nothing there right now. I'll show you how to do this when I have a part set up. So watch the video after this for part setups, and I'll go a little bit more into that. So the temperature is, we want to keep it at 70, and how we control that is we come over here to the chiller. So we need to turn on the chiller, and we just hit this button. It'll make quite a bit of noise, and the chiller will run, and that is what keeps this at 70 degrees. If you forget to turn on the chiller, your part will actually scorch, and you will most likely break wires. So remember when you're cutting to turn on the chiller. The other thing to watch is this deionization level. So this deionization level needs to stay around 10. When you're cutting, it'll creep up a little bit, but for the most part, once you see it start to go to 11 or 12, then what needs to happen is we need to replace the resin that's in this tank back here. So this tank is what does the deionization, and it's full with resin, and once you see it start to creep up, that needs to be replaced. So I'm gonna lower the tank back down to the table, and when you hear a click, the door will open back up. That's also when this gets to 0. So this is the manual page that we've been going over. You won't really use the parameters page, but you will use, the biggest one is the measure page. And so on the measure page, we have all sorts of different ways of basically finding your part. You can detect edges, center points, and stuff of that nature. In the part setup and part cutting video, I'll go over this in more detail, but honestly, there's a lot of information here, and you can, do corner finding, you can do all sorts of different things. Other than that, I think the only other page that we'll use is this maintenance one a little bit, and that's to turn on the 2 pumps. And then the other thing is, when you change out the wire, you want to update the remaining length to be equal to the full length, basically telling it that your wire, how much wire is left, and that will be indicative of, on the front page, how much wire is left. So the 13%, if I had changed that to the full amount, that would be updated to 100%, and that just kind of keeps track of the wire. Other than that, I think that's everything, and everything else I'll cover in the next video on how to cut a part. Thanks.
Kesim yolunu G ve M kodları ile programlayınız. İş programının aktarın ya da yazın ve kontrol ünitesinden giriniz. Fonksiyon seçim tuşlarını kullanarak yardımcı ünitelerin devreye alınmasını sağlayınız. El kumanda panelini açınız. Programların hatasız çalıştığını görmek için mutlak simülasyon yaptırınız. Kesim yolunun grafik ekranda simülasyonunu yaparak takım yollarını görünüz. Nozulların ve kılavuzların bağlantılarını kontrol ediniz. Tezgaha tel takarak diklik ayarını yapınız. İş parçasının düzgün bağlanıp bağlanmadığını kontrol ediniz. İş parçasını tezgah tablasına bağlayınız ve referans noktalarına göre pozisyonlandırınız. Tel gerginliğinin uygun olmasına dikkat ediniz. Tel tansiyon ayarlarını yapınız. Tüm tezgah parametrelerinin düzgün olarak ayarlandığına emin olunuz. İş parçasının tezgah ayarlarının tamamlanmasından sonra kesilmesine başlayınız. Kesim sonrası nozul ve kılavuzlarını sökünüz. Çalışma sonunda tezgah temizliğini düzgün olarak yapınız. Kılavuzları temizleyiniz. Nozulları temizleyiniz.
Times you just need to clean them for monthly maintenance, but also these can, if they get too dirty, they can lead to wire breaks because debris will build up on the guides, which will cause friction on the wire. If you're seeing multiple wire breaks, but you're not seeing jams in the lower head or anything of that nature, a lot of times it is because the guides have built up debris inside of them. So today I'll show you how to appropriately take them apart, clean them, put them back together, and then recalibrate the alignment of the wire so that you don't lose any tolerance on your cutting. All right, for this one, we're gonna take apart the upper and lower nozzles. These parts are pretty fragile. You're gonna need some custom tools from GF Machining. They come with the machine. So first we're gonna take apart the lower head. So we'll need this tool. First, we're going to take off the plastic nozzle on top. So this is just a plastic nozzle. Under the nozzle, there are two spacers, and these are actually custom for each machine and might change over time. What this does is sets the distance between the nozzle and the bottom of the table. These should be washed off and replaced. And now you have this ceramic part that you need to be gentle with. It's actually just finger tight, so all I did was spin to the left, but be very careful. Underneath is the assembly of the lower nozzle and can spill out. So sitting on top is actually the guide right there. So you have these two parts that need to be cleaned and washed. I'm going to go set all of this on the table so that we can wash it later, and then we're going to do the upper nozzle. For the upper nozzle, we're going to use this custom tool. First, we're going to use this side, which has two pins, which mates with the plastic cover on top. And so we're going to use that. Yeah, no, I'm going to need a pipe wrench. All right, so to take this off, a lot of times it gets, the upper nozzle gets tight, and I like to use some sort of leverage, pipe wrench or what have you. So with this, two parts come off with this. The plastic nozzle, and then this is the diffuser that helps to align the jet of water that helps for threading. Now we still need to get the guide, and what we're going to use is the other side of this tool. Basically, there's almost a nut up there, and we need to use this. And this will align with that nut. Once again, be careful because the guide itself is inside of here and is going to come with it. Inside here is actually three parts that we're going to bring over to the table. All right, so now that we have both nozzles sitting here, so what we're going to do is go through kind of disassembly and cleaning of each one. Up here we have the lower nozzle, and here's the upper nozzle. We still actually haven't taken apart the upper nozzle completely. There's actually four parts in here. So inside of here, taking it out, this is kind of the housing for it. This is another diffuser. This is another diffuser for making sure that the wire is guided through. This is the actual guide itself, and this is another housing. Okay, so now what can happen, especially on the small guides, is they can build up material as the wire goes through. And so they need to be cleaned every once in a while to prevent wire breaks. Once again, all I'm going to use is isopropyl alcohol. And what I actually do is the smaller parts, I just actually bathe them for about 30 seconds and shake it. And then I just blast water through to kind of loosen up any of the dirt. And then the rest of the parts just wipe off also with alcohol. Here you can see that this is getting pretty chewed up. This will actually start to affect the pressure that you get with the clearing the wire. And that can start to cause problems on larger parts where the evacuation pressure is critical. These are pretty cheap and can be replaced pretty regularly. Before putting the nozzles back, you want to make sure that you clean off the surface on the actual upper and lower head, just to make sure that they seat correctly. All right, so one thing to remember, so these little nozzles or these little guides, all of them have basically an inlet to them, and what you need to remember is the wire always needs to be going in the concave section, not on the flat side. So with this one, how the stack goes is the diffuser is on the bottom, and then the guide goes and sits nicely on the diffuser. And then the other housing kind of sandwiches it all together. So you have a stack like that. And then the upper nozzle is going to sit like this. And in goes the guide. And what you want to see is it completely lying perfectly concentric with the outer housing. And now this is ready to go back on. Same with this one. So you can see there's a small little concave part here. Once again, that should be aligned with how the wire is coming in. So this should also be pointing up, and then it'll sit inside of this housing. So it'll pretty much sit like this, and this is ready to go back on. All right, so now that we have the stack all put together for the upper, all you do is kind of just place it in there and screw it on. Doesn't need to be super tight. Do it kind of gentle, make sure it goes together nicely. There is an O-ring that will start to engage, and you'll feel some friction from that. Once again, you don't need to wrench down too hard. And now, the first thing to try, because if the diffuser isn't on there correctly or something's not aligned, the jet of water won't come straight. So the first thing to do is just do the jet of water. That's coming down nice and straight. That means everything in there is aligned and we're good to go to the next step. So now we have the plastic nozzle and the other diffuser. Just place that back in there and screw this back on. Okay, so now the upper nozzle is back on, so we're gonna put on the lower nozzle. There's a couple different ways to do this. You can either put this in first and screw it on and try and flip it over, or I actually like to just kind of place it in place on there and then gently put this over top and trying to get it to seat nicely. This one can just be hand tightened. Remember to put the spacers back so that the height is set correctly. Put the nozzle back on. You don't need to wrench on these. These are plastic threads and you can just strip them. So just tighten a little bit and you should be good to go. Anytime that you replace the upper and lower nozzles, you should recalibrate the thread alignment, which we'll go over next. All right, what we want to make sure is that the wire can thread now that we put the two nozzles back on. If they're not seated correctly, if any of the guides aren't seated correctly, you're not going to be able to get the nozzle through. So once again, I'm going to turn on the pumps, make sure it's filled up with water before I move anything. And we're going to try and thread. It threaded nicely, which means that the guides are lined up perfectly and we should be good to go. Once again though, what we're going to do next is alignment calibration so that we continue to get the tolerances we want. If you don't do the alignment, you might start to degrade your tolerances. All right, so now what we're going to do is the wire alignment or wire calibration. So we're going to use this tool provided by GF Machining Solutions. Right now this is in the stored configuration. What you can do is just take this out and it's this I outlet. What you want it is it facing forward. Tighten that back down. Now it's ready to go. So what you want to do is secure this to the back. It doesn't matter where it is, just as long as it's hanging off and it's securely on there. And then what you want to do is thread the wire through the eyelet. So what I do to kind of see if I'm aligned, I just turn on the jet, and the jet will kind of tell you where you need to go. So now I can see that it's going through the middle, so I know that I can thread it. Okay, so now the wire is threaded through the eyelet, and we're going to come back over here. We're going to select here. So here's your normal screen. What you want to do is go over to the maintenance page, and you want to go down to setup, and then the alignment tab. And the test we're going to run is called GAJ, and it gives you kind of a schematic. This first one, the ZB parameter, is from you can see it in the picture, from the bottom of the table to the middle of the eyelet. So if you haven't set this before, if you get a new calibration tool, you actually need to measure the thickness of your of the stand and then the thickness divided by 2 of the eyelet and add them together and enter that here. I've used this eyelet before, so I know that 0.815 is correct. So what we're gonna do, we're gonna close the door, we're gonna hit go. The first thing it says is the upper head must be around 15 millimeters over the eyelet. This doesn't have to be perfect, but we know that the thing is 0.815. We want to be at about 1.4055. Right now we're at 2.03, so I'm going to lower it. So like I said, it says you need to be about there, so this is close enough. I know that we're 15 millimeters over top, so now we can run the rest of the test. It's going to take about 10 minutes to finish. Once you get back, if you don't have any warnings, that means it was successful and you can go ahead and cut your part.